Let's go over alkyl halides and we're going to talk about electrophiles and nucleophiles. Now, an alkyl halide is simply a compound that has an alkyl group and an halogen. Alkyl groups can be a methyl, an ethyl, we can have a propyl. So just these groups, these are alkyl groups. Or we can also have isopropyl and all those. So when we get to attach any halogen, for example, bromine, chlorine, fluorine, then these are alkyl halides. Now, to understand electrophiles and nucleophiles, first we are going to consider simple acid to base reactions. So let's say we have got a chlorine atom that is attached to hydrogen, and this compound gets to react with ammonia. Now we know that ammonia has got two lone pairs of electrons. So we're going to show using curved arrows the movement of electrons. So when you are using curved arrows, you are going to show the movement of electrons. So a full arrow like this means two electrons are moving. When you show just like this, then only one electron is moving. Now, you don't use curved arrows to show the movement of atoms, only the movement of electrons. So these two electrons can move from here, they can come and attach to the hydrogen. Now that is going to make four electrons in the outermost shell, because we also have these two electrons on the hydrogen, and you know hydrogen cannot support that. So because of that, this is going to make this bond to release those two electrons to go on the chlorine. And so what we are going to have as a product is chlorine alone with those two electrons which have been released, because it has got more electrons like that. So we have got a concept of formal charge. So the way we are able to see this chlorine, of course, these are two electrons. It has also six other electrons which we just didn't show. Okay, it has six more electrons. So it has gained two, these other six which it already had. So what will be the formal charge? So formal charge is simply the net positive. Formal charge is simply the charge which is on an atom, let me simply say. So in this case, how do you get to calculate it? You say valence electrons on a free atom minus valence electrons which are assigned to that atom, right? So we know that chlorine is in group 7, so it has got only 7 valence electrons, minus in this compound it has got how many electrons, or just where it is here, because it has gained 2 more, so it's going to have 8. So 7 minus 8, that will give us a negative 1. So because of that, this chlorine is going to have a negative 1 charge. Okay, so it carries a negative charge like that. And then when these two electrons go on the hydrogen, so we are going to have an hydrogen now attached to ammonia. So this is what is going to be formed. Okay, so this compound that gets to donate electrons is called a Lewis base. Lewis base is an electron pair donor. And then this compound which gets to receive electrons is a Lewis acid. Lewis acid is an electron pair acceptor. So same when we have got, let's say, chlorine that is bonded to aluminium, another chlorine here, another chlorine here, and then we are reacting this compound with ammonia. Still this ammonia has got two lone pairs of electrons. Now from this compound that we're able to see here, chlorine, if we check on the periodic table, fluorine is the most electronegative atom, meaning that it gets to have a stronger pool of electrons towards itself in a covalent bond. And those atoms which are near chlorine are more electronegative. Okay, so now in this compound we have got a metal and a non-metal reacting. So basically this is an ionic compound, right? And you know that a metal forms a positive charge. Now in this compound, this metal is just going to have a partial positive charge, and the chlorines are all going to have a partial negative charge, because they're more like pull electrons towards themselves, because they are more they are more electronegative than aluminium, though this is not necessarily a covalent bond. Now, because of this, these electrons are negatively charged. The electrons which are negative are going to be attracted to the positive aluminium, like that. So what you are going to see is that, well, aluminium only adds 6 electrons here. So we know that aluminium, for it to be stable, it needs to have more electrons, like 8 electrons. So what you are now going to form is this compound. You are going to have aluminium here, you are going to have chlorine here, you are going to have chlorine here, you are going to have chlorine here, then you are going to have now ammonia attached to this side. Now if you consider aluminium also, aluminium has got 3 electrons in the outermost shell because it is in group 3, minus, now it has got 4 bonds, meaning that from each of these bonds there is 1 electron that is for aluminium. So 3 minus 4, that is going to give us the negative 1. So that is going to be the charge for aluminium in this compound. And then nitrogen, of course, for it to have, when you have got ammonia like this, nitrogen has got 3 bonds, it's going to have what? It's going to have a charge of 0. But because it has got an extra bond, it is now going to have a positive charge. Or you can show it like this: nitrogen, hydrogen, hydrogen, hydrogen. Of course, there is aluminium attached this side. So nitrogen, also the formal charge, nitrogen has got a valence of 3, minus the electrons assigned to this nitrogen in this compound, they are 4. So 3 minus 4, actually it's not even the 3 minus 4. So nitrogen is in group 5. That is what I forgot to say. Nitrogen is in group 5, meaning that, remember we said formal charge is valence electrons minus electrons assigned to that atom. So since it is in group 5, it has got 5 electrons in the atom shell, minus each of these bonds has 1 electron for the nitrogen, minus 4. So that is going to give us a positive 1. That's the formal charge for the nitrogen. So this is it. Now same in this compound, ammonia is donating a lone pair of electrons. So this is a Lewis base. And then aluminium is receiving a lone pair of electrons, that is going to be called a Lewis acid. Now, these compounds which get to donate a lone pair of electrons, okay, electron pair donor, these compounds are the ones, okay, which we call nucleophiles. Why are we calling nucleophiles? They are negative, so they want the nucleus of another atom. Those are nucleophiles. Now these compounds which are mostly positive, you can see this one has got a partial positive charge. Even here chlorine is going to have partial negative, so one is going to be partial positive because chlorine is more electronegative. So those compounds which are positive, sometimes they cannot be positive, but with a charge of 0, which like to receive electrons, those are called electrophiles. Electron loving, so those are electrophiles. Now just here we need to understand something which is called electrolysis. So electrolysis is simply the breaking or the cleavage of a bond. So when a bond gets to break and then one atom carries 2 electrons instead of sharing the electrons equally. So there's also uh, another kind of cleavage. Now that's not electrolysis. If this is electrolysis, then you should have something else that is homo, where the 2 electrons are going to be shared equally. Alright, so since this is organic chemistry, let's say we have got a chlorine here, and let me say carbon, since we are talking about organic chemistry and the most important atom is carbon, and then this carbon has got 4 bonds. Now on this one end it is bonded to some atom which is more electronegative than itself, meaning that this atom is going to carry a partial negative charge and then the carbon is going to have a partial positive charge. So when this bond is to break, the one which is partially negative, which is more electronegative, is going to take these 2 lone pairs of electrons on itself like that, and then the bond is going to break. That is electrolysis, okay, because the chlorine is going to remain with only 3 bonds. It has got it is missing some electrons. You can see it has only 6. So it's going to remain with a positive charge because it needs electrons, right? It remains with a positive charge. And then the Z, which has gained those 2 electrons, we'll show it like that. It has gained those 2 electrons. It's now going to have a negative charge because it has gained more electrons than it was supposed to have. So this is what is going to happen. This is the electrolysis here. Now, this carbon that remains when this kind of reaction happens, where the bond breaks and the more electronegative atom gains the 2 electrons instead of the carbon, this carbon that remains is going to be called a carbocation, or others would say carbocation. So the reason as to why we are saying that is because this is a carbon atom which is positively charged. That is a cation, it is positively charged. So this one is a carbocation. So we are saying that in a electrolysis reaction, it is going to lead to either the charge on carbon being which is a carbocation, as we can see, carbocation, others would say. So the charge can either be positive or negative. That is an high electrolysis reaction. We can have another scenario where we've got now the same carbon bonded to 4 different things like this. Now instead of Z being more electronegative, carbon is more electronegative than that one, meaning that this one is going to have a partial negative charge, then the Z is going to have a partial positive charge. So when this bond is about to be broken, it is the carbon which is going to take up those 2 electrons because it's the one which is more electronegative. And so what we are going to see is chlorine with these bonds like that, and then those 2 lone pairs of electrons are going to be here, and then plus now the Z. So since the Z has lost those 2 electrons, is going to be negatively charged, then the carbon is going to carry a positive charge, right? So this is what we are going to have, and in this case this carbon is going to be called a carbanion or carbon, and this is an ion now from carbon, so carbanion. So that is the carbon that is formed from this reaction when the carbon was the one which was more electronegative. So it is from here that we get also the concept of electrophiles and nucleophiles. They are those atoms which love the nucleus, others love electrons. Okay, so since we have mentioned all of these, at least we understand now. Let's start with an electrophile. So I'll start with the same carbocations which we already saw how they were formed. So carbocations, we had the carbon with only 3 bonds because it lost electrons, and then it had a charge of positive 1. Okay, it has a positive charge. So when you get this carbocation which is formed, you get to react it, let's say, with an atom that has got a lone pair of electrons. So since this bromine has got a lone pair of electrons, it's going to be negatively charged. Okay, it's going to be negatively charged. So because of this, these two are going to be attracted to each other. And so these 2 electrons are going to be attracted. Remember we said you use these arrows to only show the movement of electrons. So it is going to go like that. And what are we going to have as a product? You are going to have now the bromine attached to the carbocation. Okay. So we're going to have carbon with 3 bonds like that, and then you are going to have now the bromine attached there. Actually, I've written another thing. We are using boron instead of bromine. All right. So this is what we are going to form. Now, this compound which is seeking electrons, the carbocation is positive. It is seeking electrons, so we call it an electrophile. Why refer to as an electrophile? Okay, this is electro is just coming from electrons, phile means loving, so electron loving. So this compound which is positive loves electrons so that the charge can be neutralized, right? So carbon atoms which are electron poor, like the same one which we are able to see here. Why are they electron poor? Because of polarity. You have got a pole, like you have got a positive charge. So sometimes they cannot be carbocations, can also be electrophiles. So this one is a carbocation. We've seen that it is an electrophile. It loves electrons. But we can have some which are just electron poor, but they are not carbocations. Right? For example, we can have this compound. We have got a carbon double bonded to oxygen like this. So this one doesn't have any charge. This carbon doesn't have any charge. And then this oxygen has got two lone pairs of electrons. Okay, you have got this compound. You can see that this carbon is already balanced because it has got four bonds. Even the oxygen has got 8 electrons, so it's already balanced. Now, because of polarity, you know that oxygen is more electronegative. So this one, oxygen is going to carry a partial negative charge. The carbon is going to carry a partial positive charge. So because of this polarity, when you get to react this compound with a bromine, and we know also the bromine as a negative, and I've put it this side strategically because the negative interacts with the positive. And so what you are going to see is that these two lone pairs of electrons are going to be able to attack the carbon there. And at the end, what we are going to form is B. Now, since carbon cannot have more than 4 bonds, this other bond that we're able to see here, one of these bonds is going to break. Like carbon can't have more than 4 bonds. So this bond is going to break, okay, taking the electrons on the oxygen. And so we're going to have a boron attached to a carbon, and then it will remain with 2 bonds, even a single bond with oxygen, and then oxygen is now going to have 3 lone pairs of electrons. Now, because oxygen has got 3 lone pairs of electrons, the valence electrons on oxygen is in group 6, minus the electrons assigned to this 2, to this oxygen 4, 6, plus 1 electron in this bond that is coming from the oxygen, that is 7. So oxygen is going to have a negative charge. So this is what we are going to form, oxygen with a negative charge. So this is the compound that is going to be formed. So this one is also an electrophile, even if it is not a carbocation. So it can either be charged or not charged as long as it is electron poor. All right. So these are carbocations. What of I mean, these are electrophiles, which can either be carbocations or not, right? And from basically what we are able to see here, since this one needs electrons, then it is going to be, we can also refer to them as Lewis acids because they need electrons, right? Lewis acids. And then those which get to donate electrons, those are Lewis bases. And then we can look at now nucleophiles. Phile is still meaning living, but here you have got nucleo meaning the nucleus. So here we are going to talk about carbanions. Those which are positively charged, carbon atoms which are positively charged. So let's say we have got a carbon here, okay, and then we have got, let's say we have got like this. Now, carbanion, I said positively charged. That was just a slip of the tongue. Carbanions are negatively charged, not really positively charged, right? So those are nucleophiles. Now, let me just remove first this. So in this case, the reaction that is going to happen is you are going to have a nucleophile. It can be the same carbanion which I've mentioned. Now we know that a nucleophile has got more electrons, right? It has got 2 more electrons. Remember when we had the compounds such as you have got a chlorine, a carbon bonded to these compounds, and then Z, and then the bond breaks, it goes like that. What you are going to have is chlorine with only 3 bonds, and then you are going to have Z with 2 lone pairs of electrons, and then it will be negatively charged. So this is what we call a nucleophile. It has got a lone pair of electrons, and then it is negatively charged like that. Okay. So when you have got this nucleophile, you get to react it with something that that has got a polarity or which lacks some electrons. Let's say, for example, we react with the same compound that we saw on the previous example, this one. So what is going to happen in this reaction? So the carbon, I mean the nucleophile which has got electrons, the two electrons are going to go and attack the carbon. Now carbon can't have one bond, two bonds, three bonds, four bonds, plus the five, the fifth bond which is coming in. So this bond is going to be broken, taking the electrons here. And so what we are going to have is a nucleophile attached to a carbon with bonds like that, and then oxygen. Then we are going to have three lone pairs of electrons. And so here is the nucleophile, the one which is the nucleus loving. It loves the nucleus of the portion of the compound that is partially positive, because we know that carbon is less electronegative than oxygen. And then the one which loves the one which is receiving the electrons, that is the electrophile, because it needs electrons. All right, it loves electrons, or it needs electrons. That's the electrophile. So this is the reaction that we're able to see between an electrophile and a nucleophile. Let's look at another example. So we can have this compound, a carbon, like this, and this carbon has got a positive charge, and it is reacted with a nucleophile, which has got a lone pair of electrons. So what we are going to see is that these two lone pairs of electrons, that is one lone pair of electrons, two electrons, that's a pair. So we're going now to form a carbon with now four bonds, okay, the nucleophile there. So this is the compound that we are going to be able to form. So when you have got, what would be this? Is this an electrophile or a nucleophile? Try to identify it. Which one is the electrophile and which one is the nucleophile? So A wants electrons, so it is an electrophile. B is the nucleophile. We can even see from the symbol. Okay, let's try to write the reaction that is going to occur between this compound. So we have got this compound which we are reacting with a cyanide. No, cyanide has got a negative charge because there is a lone pair of electron here. Okay. So this is the compound. Now what kind of reaction is going to happen in this reaction? Alright, so the reaction that is going to happen, now since we have got this one with a lone pair of electrons, and then, well, here we have got, this is an aldehyde functional group. So this oxygen has got two lone pairs of electrons. And so this side, it is attached, of course there is a carbon here, this side is attached to a carbon, this side we have got the hydrogen. So what is going to happen is that between this oxygen and this carbon, oxygen is more electronegative, meaning that it carries a partial negative charge. And then this carbon of the aldehyde is going to carry a partial positive charge. And so this compound with the lone pairs of electrons is going to attack this carbon which is here, which has got a partial positive charge, because this one has got a partial negative charge. When that happens, this carbon is going to have one bond, two bonds, three bonds, four bonds. The fifth is the bond that is coming in, and that is not possible. So one double bond here is going to be broken. So the bond is going to go on the oxygen, right, as a lone pair. So what we are going to see as the compound formed, we're now going to see a single bond here, and then we are going to have also an hydrogen here, and then this now is going to attach to that carbon. What we are going to see is here the attachment point. We're going to have a carbon. Remember, this carbon is triple bonded to a nitrogen. So this is what we are going to have. Now if I want, I'll not show this carbon, because we know that in organic chemistry, when we just see any linkage or any change of direction, then there should be a carbon there. So I can also write it like this. So this is the compound that is going to be formed from this reaction. Alright. So now which one is the electrophile and which one is the nucleophile? Is it A electrophile or nucleophile, or B. Now, since B has got a lone pair of electrons and it is more donating, or it is attacking the other one, that is the what? Nucleophile. It loves the nucleus. Now, the one which is being attacked, that's the one which loves these electrons. So that's the, this one is the electrophile, this one is the nucleophile. Let's also try to see one thing. Let's try to see the reaction that is going to happen between dimethylalanine and boron trifluoride. So here dimethylalanine and boron trifluoride. How is the reaction mechanism for this one? What would be the mechanism of the reaction? Okay, so let's first write this as a structure. So obviously the central atom is going to be the nitrogen, and then we have got hydrogen on one side. Okay, and then we have got, I've actually, okay, we have got hydrogen on one side, we have got the CH3, we have got also CH3, and then we have got another CH3. Oh, I'm writing a wrong compound here actually. Okay, so I've got a nitrogen on the middle, we have got carbon with the 3 hydrogens, we have got another carbon with the 3 hydrogens, like that, and then we have got a nitrogen. Let me put a nitrogen here. So this, we are bonding it, we are reacting with boron trifluoride. So I've got a boron, a fluorine here, another fluorine there, another fluorine here. Now we know that when nitrogen is only attached to 3 things, then it's going to have a lone pair of electrons. So here is a lone pair. Okay, so what is going to happen in this reaction is that the oxygen, I mean the nitrogen, which has got lone pair, is going to donate its lone pair to this one, and what we are going to form is a nitrogen attached directly to a boron, and then you are going to have a bond here, fluorine bond there with bond there, then a bond here, and a bond here. So this is the compound that you are going to have. This is a hydrogen, it's not a nitrogen, this is this hydrogen. So from here, this one which is donating a lone pair, this is the Lewis base, and then this one, this is the Lewis acid. Alright, so basically this one which has got a lone pair of electrons, which is the Lewis base, is also the nucleophile because it needs the nucleus of the other atom. The Lewis acid needs electrons, so this is an electrophile. Thank you so much for watching. Hope this was helpful, and please remember to subscribe and also share the video.